In this lecture, we discuss about differential equations. So, what is the meaning of differential equations? An equation involving the dependent variable and independent variable and the differential coefficients of various order is called differential equation. Or we can simply say that an equation involving differential coefficients is called a differential equation. For example number one, dy dx minus y equal to 0. So now this is called differential equation. Why? Because here dy is the dependent variable, x is independent variable, and dy dx is the differential coefficient of y with respect to x. So this is an equation in which dependent variable y, independent variable x, and the derivative of y with respect to x is present. So now this is called differential equation. Similarly, the second example, dy dx is equal to cos x, is also an example of differential equation. Now d2y dx square, which is equal to 0, is also a differential equation. 2x minus y times of dx plus y minus x times of dy equal to 0 is the fourth example of differential equation. Similarly, the fifth example is root over 1 plus dy dx, which is equal to d2y dx square, is also an example of differential equation. Sixth is dy dx is equal to x plus y minus 3 upon 2x minus y plus 1 is also the differential equation. Similarly, del z del x minus del z del y equal to 2. This is also an differential equation, right? So eighth, del z del x whole square plus del 2z del x square plus del z del y equal to 2 is also a differential equation. So these are some differential equations. So differential equation is an equation in which differential coefficients are present in the given equation. So these are 10 examples of differential equation in which we are using the dependent variable y, independent variable x, and differential coefficient of y with respect to x, or partial differential coefficient z with respect to x and y. Now let us see how many types of differential equations are exist. So there are two types of differential equation. The first one is called ordinary differential equation. Differential equations involving only one independent variable and one or more dependent variables and their derivatives with respect to independent variables are called ordinary differential equation. So ordinary differential equation is a differential equation in which there is only one independent variable present. Let us see, for example. Example number one, dy dx minus y equal to 0. Here x is only the independent variable. Here also x is independent variable. In the third example, d2y dx is square equal to 0. X is only one independent variable. Fourth example, dy 2x minus y times of dx plus y minus x times of dy. Here also x is only one independent variable. Similarly, root over 1 plus dy dx is equal to d2y dx square is also an example of ordinary differential equation. Similarly, dy dx is equal to x plus y minus 3 upon 2x minus y plus 1 is also a differential equation. So these are called ordinary differential equation. Ordinary differential equation is an equation in which only is a differential equation in which only total derivatives are present. Total derivatives like dy dx, dy dx, d2y dx square, dy dx, d2y dx square, dy dx. So such type of differential equation is called ordinary differential equation. The second type of differential equation is called partial differential equation or PDE. Differential equations involving two or more independent variables and one or more dependent variables and their partial derivatives with respect to independent variables are called partial differential equations. Let us take some example. Del z del x minus del z del y equal to 2. So now here z is only one dependent variable, but here x and y are two independent variable. So such type of differential equation is called partial differential equation. So it can be also defined in one line. Any differential equation in which partial derivatives are present is called partial differential equation. So these are some examples. Del z del x whole square plus del 2z del x square plus del z del y equal to 2 is the another partial differential equation. Del 2z del x square plus del 2z del y square equal to 0 is third partial differential equation. Similarly, del 2z del x square plus del 2z del x del y plus del 2z del y square equal to 0 is also a partial differential equation. Why? Because partial derivatives are present in this differential equations. Now let us define the two very important terms. The first one is called order of a differential equation. Order of a differential equation is the order of highest ordered derivative involved in the given equation. For example, dy dx minus y equal to 0. This is a differential equation. So what is the order of this differential equation? So we have to just see here how many derivatives are present over here. So here we have only one derivative dy dx is present. So the second question is how many times or what is the order of this differential equation? Order means it is first order derivative is differentiated one time, two time, three time, four time. It means its order. Now if the there is only dy dx means its order is 1 because it differentiated only one time. If we have a differential equation which is in which the derivative which whose order is 2, then we say that that is the second order differential equation and so on. So this is what it is, a first order differential equation because it is because it contains only the first order derivative. If we take the second example, it is also the first order differential equation because it contains only the first order derivative. If you see the third example, just look here. Here, this is differentiated twice, right? So this order of the differential equations, order of the derivative is 2. So therefore, order of differential equation is also 2. Similarly, here the order of differential equation 2x minus y times of dx plus y minus x times of dy equal to 0 is only 1. Now, if you want to find out what is the order of root over 1 plus dy dx is equal to d2y dx square. So highest order derivative is d2y dx square. So its order is 2. dy dx is equal to x plus y minus 3 upon 2x minus y plus 1. Again, it highest order derivative present in the given equation is only 1. So its order is 1. Similarly, we have another examples. Look here. This is the partial order differential equation, but in the both the cases, the order of the derivative are 1 only. Now here, just look here. It is del z del x whole square, del 2z del x, del 2z del x square. So the as per the definition of order of differential equation, what is the highest order derivative present in the given differential equation? That's order is called order of the differential equation. So now here del 2z del x, it is even though its power is 2, okay, but this is the highest order derivative present in the given differential equation. So order of differential equation is 2. Here also order of differential equation is 2. Here also the order of differential equation is 2. So this is the This is the order of differential equation and its related examples. Now let us define the another more important things which is called degree of a differential equation. The degree of the differential equation is the power of the highest order derivative when the differential coefficients are free from radicals and fractions. So degree of a differential equation is nothing but a what is the power of highest order derivative present in the given differential equation when the derivatives are free from radicals and fractions. So let us take one example. Now here, this is very simple differential equation. What is the highest order derivative? It is dy dx and its power is 1. So its degree is also 1. Second example, degree 1. Third example, it's also highest order derivative is d2i dx square, but its power is 1. So its degree is also 1. Now in the fourth example, degree is 1. Fifth example, now just look here, there is a root sign over here. So we have to remove the root sign. So we have to take a square on both sides. So the square root will be removed and its degree will be, its power will become 2. So highest order derivative is d2y dx square and whose degree is 2. So the degree of this differential equation is 2. Here also the degree of dy dx is 1. Similarly, the power of del z del x and del z del y are 1. So degree is 1. So in each and every example, the degree of the differential equation is 1. Now here, if you see the nth example, del z del x whole square plus del 2z del x square. So now, since according to the definition of degree of a differential equation, we have to only observe the highest order derivative and its power. So the highest order derivative is del 2z del x square and its power is only 1. So the degree of differential equation is 1. Let us go to the next topic. What is the different types of solution of differential equations? So the first thing is called solution of differential equation. A solution or primitive of a differential equation is the relation between dependent and independent variables which is free from derivatives and satisfied the differential equation. So this is called solution of differential equation. So now solution of differential equation is a relation between dependent and independent variables which is free from derivatives and satisfy the differential equation. Similarly, there is a one more solution which is called general solution of differential equation. So a solution in which the number of arbitrary constants equals the order of the differential equation is called a general solution or complete integral of the differential equation. It means any solution. Now the solution we have already defined. What is solution? Solution of a differential equation is a relation between dependent and independent variables and which is free from derivatives and satisfy the differential equation. After that, there is one more condition, but that is called the number of arbitrary constants equal to the order of differential equation. In other words, general solution of a differential equation is the relation between dependent and independent variables which is free from derivatives, satisfies the differential equation, and which contains the arbitrary constants which is equal to the order of the differential equation. So this is called general solution of a differential equation. The next thing is the particular solution of a differential equation. The solution obtained from the general solution by assigning particular values to the arbitrary constants is called particular solution. So particular solution can be obtained from the general solution of a differential equation by putting some particular values to the arbitrary constants. Now there are two very important facts. The one is an arbitrary constant may be written in such a form as to make the answer simple. Hence, It may be written as sometime we can write C, sometime we can write log of C, sometime we can write down sine of C, sine inverse of C, tan inverse of C, e to the power C, and so on. So now the arbitrary constant can be written in this form so that we can simplify our answer according to the given question. Now, the total number of arbitrary constants in general solution is equal to the order of the equation. So these are two very important facts which is useful in the differential equation. So in this lecture, we studied about what is the differential equation, what is the different type of differential equation, and what is the order and degree of the differential equations. Thank you.